Module 3, problem number 5. An interactive poll found that 325 of 2,334 adults aged 18 or older have at least one tattoo. Part A, obtain a point estimate for the proportion of adults who have at least one tattoo. So remember, the proportion is going to be the number of successes, in this case, the number of people with at least one tattoo, 325, over the total number in the sample, n. So just by putting that into the calculator, we get 0.139. Let's check our answer. Okay, so part B, construct the 90% confidence interval, select the correct choice below, and if necessary, fill in the answer boxes to complete your choice. So first, I'm just going to touch on the requirements. We're not going to go through this as part, I've already verified it. Just remember, it must be the case that n times p hat times 1 minus p hat is greater than or equal to 10, and n is less than or equal to 0.05 n. Remember, little n is the number from your sample, big N is the number from your population. So in this case, we're good there. So let's look at the 90% confidence interval. So first, we're going to just touch on how to do it manually, and then I'm going to show you how to do it in Statcrunch. I do highly recommend doing this a couple times manually just to understand the mechanics of it and understand what's going on. But for the rest of the course and for this assignment, you can use Statcrunch. There's a little room for error when you do it manually anytime. When you do it in Statcrunch, it's a little less error prone. So let's look at this manually. So just from what we were just looking at, we know that the lower bound is p hat minus z alpha over 2, all times the square root of p hat times 1 minus p hat over n. So if we were just to plug in our, first let's look at how to find that z alpha over 2. That's a tough number to find. So I'm going to go back to our lesson from this week. Scroll back up. It's perfect that we actually use this example. So this is an example of looking at finding that critical value of z alpha over 2. Alpha, remember, is this number right here. 1 minus alpha times 100 equals your confidence level. The other way you could think of is if I'm just looking and I have a 90% confidence level, alpha is going to be 10 because that's 100 minus 90, and then divide it by 2. That gives us 0.05. So when you have a 90% confidence level, your alpha is 0.1, your alpha over 2 is 0.05. That means that we need to go down to our standard normal distribution table and find the closest value to 0.95 inside the table as we can. Now, I want to point out a couple things. Remember, this is symmetric. The same applies for the negative number as it does for the positive number. So you can either find the negative value of 0.05 inside the table or go over to the positive side and find the 0.95. Just make sure that your z alpha over 2 is using a positive value. If that's confusing, just ignore it and just focus on that 0.95. So here's a copy of the table. You can also go to the back of your book and look up the same thing. As you see here, we have 0.9495 and 0.9505. These are both equidistant from 0.95. As you see, they're both 0.0005 away. So we would need to average these two values. This one right here applies to 1.64, and this one applies to 1.65. So we know in this case, our z alpha over 2 is 0.1645. So we're going to plug that back in to our equation here. So again, we have that lower bound, and here's our equation, that p hat minus z alpha over 2 multiplied by this whole radical. So our p hat, as you see over here, is 0.139. We plug that in. Our z alpha over 2 is 1.645. And then our square root over here is 0.139 times 1 minus 0.13 all over 2,334. That's n from the problem. When I put that into the calculator, we get 0.127. The upper bound is the exact same thing except for subtracting, we are adding. Remember, these are the same distance from that p hat estimation. So again, plug that all into a calculator and you get 0.151. That's how you do it manually. Now let's take a look at doing this using Statcrunch. All right, so here's Statcrunch. To do this, you go to Stat, Proportion Stats, because again, we're dealing with proportions. Remember when we're dealing with the mean, we're looking at t-stats. So we're going to go to one sample because we only have one data sample, and with summary because we don't have data. If we had a data set with the columns, that would be with data. Here we're dealing with summary. So our number of successes is 325. Our number of observations is 2,034. And our confidence level is 90. Click compute. Our lower limit is 120.127 and our upper limit is 0.151. These are the same numbers we just found. So let's do this so that we can see them both. Our lower bound is 0.127 and our upper bound is 0.151. Check answer. Okay. The second part C, we're looking construct the 98% confidence interval. Select the correct choice below and if necessary, fill in the answer boxes to complete your choice. Again, our alpha in this case would be 2 or 0.02 and divide that in half and we're going to get 0.01. And then in that case, we would be looking for 99 inside of that table. So let's go take a look at that just to see how it looks a little different. So let's see, can we find our closest value to 99? Right here. See how that we have 0.9901 and that corresponds to 2.33. So our Z alpha over 2 in this case would be 2.33. I want to point something out to you guys. Down here at the bottom of this table, you're going to see this nice little summary, and this is actually a very good thing to pay attention to. These are the very common levels of confidence you will see when developing confidence intervals. You have 90%, 95, 98, or 99. It gives you the critical value Z alpha over 2. So you don't have to go finding it up in this table if you're using one of these very common percentages, 90, 95, 98, or 99. Now we just went and found that 2.33 right here with that 0.9901, which is as close as we could get to 99. As you see here down below, it also gives us that 2.33. It's the same thing, it's just an easy little table. And just for those of you watching, next week we will be talking about hypothesis testing. This will be a handy little table to use. I also included in my lesson, so make sure you see that. So right now we know that alpha over Z is 2.33. Now we could go back and chug it right back into this equation just like we did, except it would be right here instead. It would be 2.33 and 2.33. Do you see that? So it's the exact same thing. We just have a different critical value. So if there's any questions about how to type that in the calculator, let me know. Otherwise, I'm going to go do it into Statcrunch just to show you guys again the process of doing it in Statcrunch. There's two things you could do here. You could just click on options and click edit and edit this to say 98% and compute again, and it will recompute based on that 98%. You could also go back here to stat, proportion stats, one sample, and with summary and type it all back in. This is an easier way just to get that 98%. So let's go ahead and put that in. So our lower bound now is 0.122 and our upper bound is now 0.156. You see where I got that from right here? Here's lower limit, upper limit. So type those in, click check answer. Obviously we got that right. Now continue. Choose the correct answer below. Increasing the confidence level basically did what to our interval? Well, here we had a 90% confidence level, a lower confidence level, and our lower bound and higher bound were within our lower and upper bound of the 98% confidence interval. So does that mean that widening or increasing our confidence level widened our interval? Yes, it did. So that's how you go through number 5. If you have any questions, let me know.